Hello! In this video, we are going to prove the following theorem. Suppose a and b are non-zero integers, and m is an integer such that a divides m and b divides m. Then the least common multiple of a and b divides m. In other words, this is saying if m is a common multiple of a and b, then m is a multiple of the least common multiple of a and b. Now, let's first remind ourselves, given any two integers a and b, to say a divides b means b is equal to a times some integer. Or in other words, it means that there exists some integer k such that b is equal to k times a. Right? That's all that this notation means. So now, let's remind ourselves of our definitions of least common multiple and greatest common divisor. Suppose a and b are non-zero integers. Then the least common multiple of a and b is the smallest positive integer, lambda, with the property that a divides lambda and b divides lambda. Our definition of greatest common divisor is, suppose a and b are integers that are not both zero. Then the greatest common divisor of a and b is the largest integer, d, with the property that d divides a and d divides b. Now, since 1 divides a and 1 divides b, well, d is the largest integer with this property, so d must be greater than or equal to 1. So it immediately follows that d must be a positive integer. And also, in proving this theorem, we are going to use Bézou's lemma, which is a property that tells us what happens when the greatest common divisor of two integers is equal to 1. Suppose a and b are integers that are not both zero. Then the greatest common divisor of a and b is equal to 1 if and only if there exist integers s and t such that as plus bt is equal to 1. Okay, so now let's get into proving this theorem. Now for convenience, we're going to denote the least common multiple of a and b by the Greek letter lambda. Well then, by definition of least common multiple, we know that a divides lambda and b divides lambda. So since a divides lambda, this means that lambda is equal to a times some integer. I'll call that integer p. And this means lambda is equal to b times some integer. I'll call that integer q. Now, the least common multiple is a positive integer, so certainly p and q are non-zero. So, since p and q are non-zero, we can make sense out of the greatest common divisor of p and q. The claim is that the greatest common divisor of p and q is equal to 1. And for convenience, we're going to denote the greatest common divisor of p and q by the letter d. Well then, by definition of greatest common divisor, we know that d divides p and d divides q. So then, since d divides p, this means that p is equal to d times some integer. I'll call that integer I. And this means q is equal to d times some integer. I'll call that integer j. Well then, we have lambda is equal to ap, and since p is equal to di, this tells us lambda is equal to a di. But also we have lambda equal to bq, and q is equal to dj. So this is just b dj. So we can take this equality, divide d on both sides, we get ai is equal to bj. And if we divide lambda by d, well, this is just equal to lambda over d. So lambda over d is an integer because it's equal to an integer. What this tells us is lambda over d is equal to a times some integer. So a divides lambda over d. This also tells us b divides lambda over d. In other words, lambda over d is a common multiple of a and b. But since lambda is the least common multiple of a and b, well then lambda must be less than or equal to lambda over d, right? Lambda is the smallest positive integer, which has this property. So lambda must be less than or equal to lambda over d. And then multiplying d to the other side, dividing lambda on both sides, we get d is less than or equal to 1. However, we know that d is greater than or equal to 1, right? Because greatest common divisor is a positive integer. So d must be equal to 1. And this shows that the greatest common divisor of p and q is equal to 1. So, applying Bezier's lemma, there must exist integers s and t such that ps plus qt is equal to 1. And then, using the fact that a divides m and b divides m, well then m is equal to a times some integer. I'll call it integer x. And since b divides m, m is equal to b times some integer. I'll call it integer y. And now, if we take this equation and multiply m on both sides, we get m is equal to mps plus mqt. And we're going to replace the first m with ax. We're going to replace the second m with by. So then, we can replace ap with lambda. We can replace bq with lambda. So then, factoring out lambda, we get this. So this tells us m is equal to lambda times some integer, or in other words, lambda divides m. And lambda is the least common multiple of a and b, so this shows that the least common multiple of a and b divides m, which is exactly what we wanted to prove. And so this completes the proof. And so yeah, that's pretty much it for this video.